Hey guys, it's me Prince, and now we have basic idea of what exactly is an AMM in layman term. We understood the mathematical formula, that is constant product curve, which works behind an AMM. We got through multiple examples. Now we can dive deeper into the architecture diagram itself. So now we'll try to go through basic requirements, or we'll try to architect the contract. So an AMM contract is consist of four major instruction. This one is just to update the pool. So we have four major instruction, or let's say five major instruction: initialize, deposit, withdraw, swap, and update. So initialize is something where we initialize the it's something where we initialize the config itself, when we initialize the pool, when we create the pool, right? So in initialize instruction, we create a PDA where we store all the details of our liquidity pool or AMM pool. What details? We need a seed. We want in escrow also. We already discussed what is the use of this seed, and what we discussed that if we want a user to create multiple stuff, like if in escrow we wanted a single user to create multiple escrows, right? So we gave them a seed which was used to differentiate one escrow from another. Similarly in AMM, we want a single user to be able to create multiple pools by using, let's say, same asset. He wants to create an USDC and Solana pool, he wants to create another USDC and Solana pool. The assets are similar, right? But still he should be able to do that. If you want user not to be able to do that, you can remove seed from there. But if you want, then you can put seed and a different PDA would be generated, and you would be able to create multiple pool using same asset. After that, authority. Why do we need authority? We want to give user, or like the platform authority to the platform, that who is able to lock or unlock the pool, or any other stuff, like who should be able to change the fees wallet, anything other. We need authority for that. After that, we already have a slight basic idea that our AMM pool would have two different type of tokens, that is mint X for token X and mint Y for token Y. After that, what is the percentage of fees we take in each transaction? If you remember, why do we need fees? So there are people out there who are basically providing liquidity to our pool. They should earn some revenue for the work they are doing, right? They are giving you they are giving money to our pool, so they should earn some revenue on top of that. So this, some percentage of this fees will go back to them. After that, this is the status of the pool. Let's say this remains false for when there is no problem. If the pool is continuous and running, this remain false. And let's say there is some problem, some hack is going on, there is some exploit going on. So you can basically, with one instruction, you can lock the pool, and you can get all those instructions like deposit, withdraw, and swap with these constraint, that nobody is able to withdraw from the pool, nobody is able to swap from the pool, so that we can think about something, we can work on exploit and later reopen the pool. After that, we need to bump config bump and LP bump. So I think I forgot one thing in the PDA, that was to we also need to create a liquidity mint. So we are going to mint token to the liquidity providers. We need a liquidity mint. This is the bump for that, and config bump is basically bump for this config PDA. After that, you get what PDA we need. After that, in this initialize instruction, what exactly we are going to do is that we are going to create three things. There we have it. We are going to create three things. First one is we are going to create vault X. Now why do we need to create vault X? To store token X. So if you notice, our pool had two vaults. This is our liquidity pool, and our pool had two vaults, vault X and vault Y. and these are used to store token separately. So in the initialize instruction, we create both of these vault. We create vault X, we create vault Y. And why do we do that? Simply to store token X and token Y. After that, we create one more thing, that is mint LP. Now why do we need to create mint LP? Because in if you remember, in this instruction where a user was providing liquidity to the pool, we were minting some LP tokens to this guy, and that's why we need to create a mint LP, so that we can mint LP tokens to the liquidity providers. Got it? After that, after creating vaults, after creating mint, we just initiate the config. What config I'm talking about? This PDA config, and then initialize instruction is done. Very simple. In short, what exactly we do? We create vault X, we create vault Y to store X and Y tokens. We create mint LP to so that we can mint liquidity tokens back to the liquidity providers, and we initiate the config. We store everything into the config, that is our PDA. We can move on to the second instruction, that is deposit. Now our LP pool is created, but this is empty right now. There is a vault, but vault is empty. There is vault Y, the vault Y is empty. Our pool is empty right now. Nobody can come and trade. So the very first thing that is done after initialization is to deposit, right? We need to deposit something into the pool. We need to deposit both tokens into the pool so that user can come and trade, user can come and swap. So this is the instruction that does that thing, which is known as deposit. So in deposit, what exactly we do? We calculate how much liquidity tokens we are going to give back to the provider. After that, we take token X from user X ATA and deposit it to the vault X. And this instruction would be signed by user, because we are transferring token from user ATA to the vault, right? After that, we take token Y and we deposit it to the vault. We transfer from user Y ATA to the vault Y, and this should also be signed by user. After that, this user provided us liquidity, right? It's not like that he gave us X and he took Y. He's giving us both. He's giving us token X as well as he is giving us token Y. This means this instruction, he is a liquidity provider. So we need to mint some LP tokens to the user ATA, right? And since this minting process is done by contract itself, so we need signer seeds for this, because the authority of this mint is our contract. It's not any user. After that, the third instruction that we have is withdraw, and it's exactly opposite of deposit. In deposit, liquidity providers deposit both tokens X and Y into the pool. In withdraw, he simply takes back the liquidity he provided. He gave us token X in the deposit, he takes back token X. So we withdraw token X from vault and we gave it back to the user X ATA, and we need signer seeds for that. Why? Because in this instruction, token is getting transferred from vault to the user, and who owns the vault? Our contract owns the vault, so we need signer seeds for that. After that, the token Y, right? We take token Y from the vault and transfer it back to the user Y ATA. We need signer seed for that. After that, in deposit instruction, we gave some liquidity to the user, right? Liquidity tokens. Now we burn that LP tokens, and withdraw instruction is done. After that, the use of AMM pool, the most important instruction, that is swap. Swap is something that we discussed in very detailed manner in 3 trade that we done. These all instructions were basically a swap. This was swap X in, this was swap X in, this was swap Y in. So there were 3 swaps, right? And this instruction was basically a deposit, and withdraw would be exactly opposite of this. So now we can look into what exactly is swap instruction. Now we can move on to the swap instruction. So what does exactly swap does is, we already discussed it in a long manner, that user has either X token or Y token and he wants the opposite in the return, right? So let's say in our condition, user wants Y token in return and he has X. So we'll calculate the amount of token user will get for amount he deposits, right? Let's say we already went through the calculation here. In very first trade, user had 50x tokens and he wanted Y token in return. So we did the calculation for 50x token, he will get 20 Y token in return. So we'll do the calculation first, and after that we'll deposit that amount of token X from user XATA to our vault X, and the signer for this deposit would be user, because we are taking token from user ATA and depositing it in the vault. And then we already calculated how much Y token he will get, right? So we'll take that amount of Y token from vault Y and we'll deposit it in the user Y ATA. And since this is a transfer from vault to user, we need signer seed for this. So this is simple swap instruction. After that we have our last instruction, that is update. So update instruction is very simple, it does nothing. It basically helps you to lock and unlock the liquidity pool. So let's say if there is some kind of exploit, you basically what do? You check the authority first, if this user who is calling this instruction, if he has the authority to lock the pool or not, or even unlock the pool or not. And that we already set in initialize instruction, right? We set an authority in the initialize instruction. So we just check if this guy who is calling this instruction is same as this authority or not. And if this is the same guy, we basically lock and unlock the pool as per his instruction. If he wants to lock the contract, we'll check if the current status of contract is unlocked or not, and we'll lock the contract. After that, if we try to unlock the pool, we'll just check the authority if he is the correct guy or not, and we'll also check if the pool is itself locked or not, and then we'll unlock the pool. This was our last update instruction. So this is the architecture diagram of an AMM. We can dive deeper into the code itself in our next video, and then we'll try to test it after that.